We want to continue this week talking about roots and radicals. Now, you may have noticed that the notes week number doesn't always match up with the week that we're in. We've shifted things around a little bit in the course, but the notes are still the same. So don't worry about what it says there. Just follow the dates shown in your course outline, follow the dates shown on your class Moodle page, and you'll be fine. Remember, you have quizzes due this week, and you probably have a test coming up soon, so make sure you have that date on your calendar. Before we start evaluating roots and radicals, we should label a few things here. This n, the number outside, is known as the index. We'll talk more about the index in a bit. And everything inside the radical sign is known as the radicand. And of course, we have our radical sign here. So if we want to talk about square roots, a number b is a square root of a number a. Well, what does that mean? The square root of a number a is a number b. So we can say that b is a square root of a if a is greater than or equal to 0 and b is greater than or equal to 0. So in order to talk about square roots, both the radicand and the answer have to be greater than or equal to 0. Now, if we're asking for the square root of a, we're asking for a positive square root. The negative square root of a is our negative square root. This positive root is also our principal root. What about the index for a square root? Remember that the index is this number outside. But when we write a square root, we don't have a number here. What is the index for a square root? Well, even though we don't write it, we understand that the index is 2. That's important to remember as we start looking at some of the properties of roots and radicals. Let's evaluate these, but first, let's think about this principle that the square root of a times a equals a. Think about that. The square root of a times a equals a, as long as a is greater than or equal to 0. I hope you know what the square root of 49 is, but let's use this principle to think about our answer. We could rewrite the square root of 49 as the square root of 7 times 7. Oh, there's our a times a. So it equals 7. The negative root of 81? Well, we have a negative sign outside, but this is the root of 9 times 9. What is the square root, or sorry, the negative square root of 81 then? Well, it's going to be negative 9. Pause your video and answer questions 3, 4, and 5. For question 3, we see that this is the square root of 11 times 11, which equals 11. This is the square root of 3/10 by 3/10, and therefore equals 3/10. Did you get the square root of 0? I hope so, because we know that this is 0 times 0, which equals 0. And then we have question 6, the square root of -4. The problem is I cannot write this as the square root of a times a. I can write this as the square root of -2 times 2, but those are not the same. And remember, we also say here that a has to be greater than or equal to 0. This has no real solution. It does have an imaginary solution, but lucky for you, we're not going to worry about those. We say that the square root of a negative number is not a real number. We say there is no real solution. Let's stop here for now.